Today we will highlight and demonstrate some of the valuable features of the BlueSky GNSS Firewall involving the validated and hardened outputs. Let's begin by familiarizing ourselves with the setup used in this demonstration. On the top of the rack, the BlueSky GNSS Firewall is providing signal to a time provider 4100, as well as an SSU 2000. LiveSky GNSS signal is received by an antenna and the signal is fed into the GNSS in port on the firewall. The LiveSky signal is heavily interrogated by the BlueSky GNSS Firewall. If the signal is deemed valid, the LiveSky GNSS signal is passed through the validated output. If anomalous conditions are suspected, the validated output is cut off and no signal is sent to downstream equipment. The hardened output is always sending a basic GNSS signal to downstream equipment. This signal is a synthesized GNSS signal and is therefore always safe for downstream equipment in instances where GNSS signal is being jammed, spoofed, or in a completely GNSS-denied environment. Many customers are adding or transitioning existing legacy timing systems such as the SSU 2000 with packet timing. Because of this, in many locations where an SSU is already deployed, a time provider 4100 is being added. This demonstration is an ideal setup because the validated output signal is sent to the time provider 4100, which includes a high-quality GNSS receiver with L1 and L2 band capabilities. And the addition of the BlueSky GNSS Firewall gives added anomaly protection to the system. The hardened output signal being sent to the SSU 2000 is ideal because the SSU does not include L1 and L2 band capabilities, nor does it have any anomaly protection. Additionally, SSU units equipped with Stratum 3E clocks have limited holdover capabilities. The hardened output feeding a GPS signal into the SSU is ideal because the SSU is able to take advantage of a high-quality GNSS receiver with L1 and L2 bands, it is protected from anomalous conditions, and the holdover performance is improved when using a BlueSky GNSS Firewall equipped with a miniature atomic clock. Now let's take a look at the live demonstration. In the top of the rack is the BlueSky GNSS Firewall, followed by the time provider 4100 and the SSU 2000. As indicated by the LEDs, the connection of the firewall, time provider 4100, and SSU 2000 are all good. Everything is connected and locked to GPS signal. Now let's disconnect the GNSS input into the firewall. This will have different results on both systems. Because the time provider 4100 is relying on the validated output and the signal is no longer valid, the time provider 4100 enters holdover. The SSU, however, stays completely locked to the GPS because the synthesized output of the hardened output does not require GNSS connectivity. To learn more about the BlueSky GNSS Firewall, the time provider 4100, the SSU 2000, or any of our other products, please visit microchip.com.